Center for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on electrolysis of some selected aqueous solutions. Over the next few lessons, we will look at several selected aqueous solutions and the different variables that affect the reactions that take place within them. We will be looking at how the concentration of the ions affects the electrolysis of dilute and concentrated solutions. We will also discuss how different types of electrodes, such as those made of copper as compared to nickel, have an effect on electrolysis. Today, we are going to look at how the nature of the ions affects the electrolysis of aqueous solutions. We are going to talk specifically about the electrolysis of aqueous solutions of dilute sulfuric acid. We will start by doing a little bit of review so we can put everything we learned today into the context of conductivity and electrochemistry. Students, if you are ready, let us begin. Today, we are going to look at electrolytic conductors. This type of conductor uses an electrolytic solution, or an electrolyte, as well as electrodes, known as the anode and cathode, to form electrolytic cells. These cells take electrical energy that is applied to the electrodes and conduct it within the liquid solution to create chemical changes. An electric circuit can be used to test liquid solutions for the presence of mobile ions. All we have to do is take an electrolytic cell, like the one we just saw, and add a light bulb between the source of the electricity and one of the electrodes. The light bulb will do nothing if the solution does not contain mobile ions. But if it does contain mobile ions, the bulb will begin to glow. Students, let us do an activity. Draw a picture of an electrolytic cell with a light bulb in its circuit. Draw what a light bulb looks like if the solution contains a small amount of mobile ions. Beside it, draw another cell with a light bulb. Draw what that bulb looks like if the solution contains a large amount of mobile ions.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. What was the difference between your two light bulbs? The cell that has the solution with the small amount of ions in it would have a weak current strength. You were correct to draw its light bulb with a very dull glow. The cell that has the solution with the large amount of ions in it would have a strong current strength. If you drew a light bulb with a bright glow for this cell, you are correct. Thus, we can check a solution's ability to provide ions by comparing how brightly the light bulb glows, if at all. This also shows us the effect ions have on the process of electrolysis. The more mobile ions present, the stronger the electrical current can flow to create an oxidation-reduction reaction, or a redox reaction. A redox reaction is a process where negatively charged ions move towards the anode and lose electrons, or oxidize, and positively charged ions move towards the cathode and gain electrons, or reduce. Oxidation and reduction separately are both half reactions. The entire process is called a redox reaction. Let us continue by using the example of the electrolysis of a liquid solution of sulfuric acid and sodium hydroxide to show these reactions. When a potential difference is applied across the electrodes, which is the amount of energy needed to move a particle from the anodes to the cathode or the cathode to the anode, certain ions move in certain directions. They also move in a certain order. This is because certain ions are discharged before or with preference to other ions. The general rule is that if two or more positive ions move towards the cathode, the lower ion in the series is discharged first. The same is also true if two or more negative ions move towards the anode. The ion lower in the series is discharged first. In the case of electrolysis of a dilute sulfuric acid solution, when a potential difference is applied across the two electrodes, only hydrogen plus ions move towards the cathode. Hydroxide minus ions and sulfate minus ions move towards the anode. At the cathode, hydrogen plus ions are discharged. At the anode, hydroxide minus ions are discharged before sulfate minus ions. This is because the hydroxide ion is below the sulfate minus ion in the electrochemical series. The electrolysis of a dilute sulfuric acid solution results in the decomposition of water to oxygen and hydrogen gas. The electrochemical series, or reactivity series, orders metals based on their reactivity from highest to lowest. Thus, the nature of the ions, or their placement in the electrochemical series, affects their movement and the half reactions they create. Students, note that the electrolysis of dilute sulfuric acid solution results in the decomposition of water to oxygen and hydrogen gases. Students, let us do another activity. Have another look at this reactivity series. In a moment, several cations and anions will appear on the screen. Order the cations and the anions based on reactivity from highest to lowest.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. The cations from highest reactivity to lowest are silver, zinc, and magnesium ion. The anions from highest reactivity to lowest sulfide are chloride and fluoride. In this lesson, we briefly reviewed the function of electrolysis as a method of conducting electricity. We also discussed the nature of ions and how this affects the electrolysis of aqueous solutions. This is all for today's lesson. Until next time, thank you, teacher. Thank you, students.